Hi everybody, very welcome to Mentour and another video podcast. As always, I hope you're doing absolutely fantastic. Today on the video, guys, traffic jams in the sky. Do they exist? And if they do, what happens if you end up in one of them and you're starting to run out of fuel? Stay tuned.
Wind 31016, ribbon right, right on right. Cleared to land 31 right. Delta 260. Yes, sir, dude.
This video is brought to you in cooperation with Audible. Now, if you're like me, you love kind of kicking back, relaxing and enjoying a good audiobook. If you use the link down here, which is audible.com/mentorpilot, or if you're in the United States and you text Mentor Pilot to 500. And in that case, you will get one audiobook for free. You get 30 days of free trial of Audible and 2 Audible original books. And one title that I think that you guys might enjoy is The Last Days of the Concorde. So check it out. Right guys, so the reason I chose to do this video was I have been in Birmingham for the last week, flying out of there. And people in Birmingham are lovely. I was sitting on the in the taxi on the way back to the airport to fly back to Barcelona, and I was chatting to the taxi driver. And the taxi driver said that, well, you know, I would much prefer your job because at least you don't have to deal with traffic jams. And that got me thinking. I realized that you guys, you people out there, you might not understand how much traffic actually does affect our everyday job. And that's what we're going to talk about today. So, to start off with, I have done videos before talking about air traffic control slot restrictions, CTOT restrictions. So, if you want to check that out, we have links to it up here. So, I'm not going to go into great detail, but what slot restrictions actually is a way for air traffic control to avoid traffic jams at our destination. They don't want to have us sitting in the air, flying around, burning fuel, if they can avoid it. So what you should be picturing is that when we're flying en route, we're following basically highways in the sky, right? The highways takes us in between special coordinates, which are geographical GPS points called GPS waypoints, or actual kind of radio navigation aids. So these highways in the sky, they kind of go through in more or less straight lines, but not completely straight lines through Europe or the United States. Okay. If something happens to the air traffic control structure, let's say a breakdown of the radar coverage or an air traffic control strike or anything like that, well, then what you should be picturing is that highway going from maybe 6 lanes to 2 lanes. So instead of having a steady flow of traffic running through the airspace, you now have only a small trickle getting through. And that's when that gets then pushed out down to the aircrafts that are waiting to take off, and they can get slot times anything from a few minutes to a couple of hours. Actually, last week there was an air traffic control shutdown in France, and I was flying on the Sunday when it happened, and I ended up sitting with my passengers on board the aircraft for 3.5 hours. Now, my passengers were great. We had a great time. We had people coming into the cockpit visiting. I was out talking to them, and they behaved greatly. But it makes, it's a huge pressure to both the pilots and especially the cabin crew who has to deal with the situation. Okay. Now, the reason that we can't let people get off in that case is because of the way that the slot system works, where whatever happened, let's say that there was a breakdown of a specific sector, if they manage to fix that, well, then those slot restrictions can just suddenly disappear. And that's when you end up with the slot that was 3 hours now suddenly being just 10 minutes. And of course, if we've taken all of the passengers off the aircraft, then we're going to have to reboard them again, and we might miss that slot, and we might have to wait even longer. And this is why we tend to keep the passengers aboard whenever there are slot restrictions like that. Okay? But basically that's what we have to avoid traffic jams to start with, slot restrictions. Just not let the aircraft get into the air. Because what you have to understand is that there is an enormous amount of flights every day in Europe, in Asia, and in America, basically every day. They tend to move in waves out of very busy airports. So if I take, for example, London Stansted, there are a lot of based aircraft in Stansted, so they will all try to take off around 6 o'clock in the morning. And the way that Europe, the size of Europe means that normally the flights are between 1.5 to 2.5 hours. So this means that if all of them takes off around 6, then 4 hours later, more of them are going to come back. So then you have an influx of a lot of traffic at 10 o'clock, same at 2 o'clock, same at 6 o'clock, so on. Those are called waves. And when those waves occur, there's a higher likelihood of an in-flight traffic jam. So how can we avoid that when we are airborne then? Well, the first thing is that you have to understand that all of the air traffic control units throughout the airway that we were flying, they're all communicating with each other. So if they see that there is a potential build-up of traffic at our destination, well then they will call their colleagues, and the colleagues will tell us to reduce or increase the speed to kind of fit us into the traffic pattern. So that's what we can do when we're airborne. We can, adapt our speed, but it's not going to make a huge difference. Maybe a couple of minutes faster, a couple of minutes slower. And this, by the way, brings me to another point, which a lot of people have been asking me. Is like, what do pilots do in order to gain time if they're en route? Can they just speed up? And the fact is, not really. We fly at a economical speed, which tends to be Mach 0.77 to Mach 0.79, which is about 77% or 79% of the speed of sound when we're in cruise for the 737. And the difference between 7.7 and 7.9 is only 5, 6, maybe 10 knots. So it's not much we can do when it comes to our speed. What we can do is ask for shortcuts. To instead of flying an entire airway route, we can ask air traffic control if there's any way we can go between one point and then directly to a point further down, so we get less track miles. And if there's not a lot of traffic, air traffic control tends to help us out with that, and that can save a lot of time. But if there's a lot of traffic en route, one benefit that we have that the taxi drivers do not is that, of course, our highways are three-dimensional. This means that, we will be trying to fly at our most economical flight level, which tends to be between 36,000 and 39,000 feet for the 737. And that's where we tend to be flight planned. But if there's a lot of traffic in the area, we might not get that. So our traffic control might tell us, listen, today you are going to be capped at 35,000 feet. That's as high as you can go. And that will still be fine with us. If we get much lower, it's going to burn a bit more fuel, but we tend to have in our flight plan something called contingency fuel, which is made, for specifically this reason. If we get a lower level or if we get diversions due to, for example, thunderstorms en route. Right? So that's what they do. They can reduce the speed, increase the speed, or they can assign us different levels in order to accommodate all of the traffic going through the sector. The same could be done on the roads, really. If we knew, for example, that there was a traffic light further ahead, we could reduce the speed we're driving in order to make sure that we have green when we pass the traffic light. And in fact, on the self-driving cars, when they come, they will likely have that kind of automation built into it to avoid traffic jams building up on the roads. But that's a completely different episode. Right, so that's if we are in the air over continental Europe or the United States, for example. What about if we fly transatlantic? Well, oceanic crossings is a different thing. So if you're going to do an oceanic crossing, there's no radar coverage over the mid-Atlantic, for example. And this means that in order for us to make sure that we have enough separation in between each aircraft, because we have to have that by for safety reasons, they comply with something called time procedural separation, which means that every aircraft that's flying over the Atlantic will have an oceanic entry point. That's a geographical point where the aircraft needs to be over. And it's going to have to be there at a specific time and flying a specific speed. So if you're flying faster, you see you're going to be there early, you need to slow down. And the reason for that is because air traffic control needs to know that this aircraft passed that point at that speed at that minute. That way they know that they have enough separation to the aircraft that's flying ahead and enough separation to the aircraft flying behind. Then during a specific point over the Oceanic crossing, every aircraft has to call in with their coordinates and the time to make sure that that nothing is happening, that everyone is there where they're supposed to be. All right, so it's slightly different when you do Oceanic crossings. So what about if you end up at your destination and you still end up in a traffic jam then? Does that happen? Unfortunately, yes. Because of the sheer volume of traffic coming into specific airports, say Heathrow in the UK or Los Angeles or New York in the US, it means that it's just not physically possible to get all the aircraft in and landing when they're supposed to. Okay. We have minimum separation in between each aircraft, so you need to be able to have a certain amount of time or mileage, depending on what type of aircraft it is, between each landing aircraft and between each takeoff aircraft. This is why you see these bigger airports tend to have dual runways, where one runway is used for takeoff and another one is used for landing. All right? But because of this minimum separation, you will have build-ups. And what happens then is that if I'm, for example, coming into Heathrow, and it's during one of these peak hours, I will be put at the top of what's called a holding pattern. Now, I'm sure as a passenger, you've probably seen this before when you end up just circling. It feels like you're just turning continuously. What you're actually doing is you're flying something called a racetrack. Okay, it's a oval form where you fly normally about 1 minute in towards a geographical point or a navigate. Then you turn, and with a rate 1 turn, it will take you 1 minute to do the turn. Then you fly straight ahead for 1 minute. You do 1 minute turn in, 1 minute towards the navigate. All right. So we keep doing that, and you get in what's called on top of the stack. That means that the aircraft that's coming into the holding pattern are at the top, and then you descend 1,000 feet each time. You get closer and closer, and when you're at the bottom of the stack, well, then you will eventually get radar vectors in to land at your destination airport, or flying a procedural in. Okay, so you end up kind of descending, still maintaining this racetrack all the way down. All right, good. Before I go any further, guys, I just want to say a huge thank you to my Patreon crew out there. You know who you are. I just received this picture from Thomas yesterday. He received a goodie bag that we just sent out to our top Patreons out there, and I'm so happy, Thomas, that you are part of my Patreon crew. And if you are out there and you want to support the work I do with the channel, then go and check out this link up here. So, what about if you get into the holding pattern and for whatever reason, maybe there's been an incident on the ground, or maybe if weather doesn't allow landings or something like that, and you realize that you don't have enough fuel to spend in the holding in order to land? What do we do then? Well, this is interesting. What you have to understand is that there are very, very set rules for how much fuel that we are allowed to have on board. We have to be able to fly from our destination to a predetermined alternate that should have good weather, and on top of that, another 30 minutes. Now, those 30 minutes are important to remember. Those are what we call the final reserve fuel. And the final reserve fuel can never be touched. Right? Should never ever be planned to be touched. Whenever you touch that, you're in what we call a fuel emergency. And I'll get to that in a second. So, when we get into the top of the stack, like I was mentioning before, air traffic control tends to give us an estimated approach time. And we put the holding into our flight management computer, the FMC, and the FMC will then tell us how much fuel we have, how much time we have to spend in the hold. And it might tell us you have 30 minutes available. Now, if air traffic control has gone in and said that, your expected approach time is in 45 minutes, well then, what we will do is we will realize that we don't have that much time. We will probably tell air traffic control that we only have 30 minutes available. And then we will start to plan for a potential diversion. So that means taking the weather for the alternate airport. It means maybe checking approach plates, getting mentally prepared for doing the diversion. But we will still stay in the holding because you never know. Maybe whatever happened on the runway gets cleared up. Maybe you get a much quicker approach than you expected. Because we always want to try to get the passengers to the destination that they want to, right? But if the time goes on and there's no update to our estimated approach time, then as we approach that time, we would have checked what kind of traffic there is at our destination alternate as well, because obviously if there's further holdings there, we're going to have to divert a bit earlier. But anyway, when the time runs out, we are going to tell air traffic control that we now need to divert to our alternate, and they will just facilitate the diversion. Now, all of this puts enormous stress on the air traffic control, especially if there's a lot of people sitting holding in the stack and all of a sudden all of them want to divert to a different airport. But this is where the skill of the air traffic controllers, especially for example in the London area, becomes very apparent. Okay. But we will divert, and generally speaking, when we do divert, we get kind of priority into our alternates. But if something else would happen there, we continuously monitor our fuel situation now during the diversion. And we tell them if we see that any change to our current clearance will render us into those 30 minutes I talked about before, we tell them minimum fuel. Still not an emergency, we just tell them minimum fuel, and that will tell air traffic control that they can't be changing us around anymore. They can't be setting us into a holding or doing a delay vector. They need to let us proceed towards our destination. Just tell them, Mentour 360, minimum fuel. That's it. Now, if something further would happen, so if they have to give us a delaying vector, for example, and we see that in our FMC, we're now below our final reserve fuel, those last 30 minutes, then by law, we have to declare a Mayday, Mentour 360 fuel. Right. This is by law. It doesn't mean that we're about to fall down. It just means that we see that we are going to land with less than our final reserve fuel. So we tell them that this is now a Mayday, which means that we have full priority. That opens up all the runways available, everything to us, because that's what happens when you call in a Mayday. But I want to emphasize this. It's still not critical. It's still not like we're about to fall down. And the reason that I want to emphasize this is because last week on Twitter there was a lot of questions coming in because a Emirates flight who was flying into one of the London airports had to do a go-around and then sit and wait, and then they diverted to an airport on the other side of London and they had to call a fuel emergency. And people were asking, why didn't they just stay? It was much closer to land at that airport rather than flying halfway across London and declaring a fuel emergency. But this is because they couldn't be sure that they could land at their destination. They had done a go-around already, so they had to divert. And during that diversion, something happened that made them start to move in to that final half hour, that final reserve fuel. And by law, when that happens, they have to declare a fuel emergency, right? Once again, not dangerous unless something further happens. Okay? Cool. Good. So that's what we'll do. You can actually commit to your destination as well. And that is if you have a reasonable certainty that you're going to land there. So let's say, for example, that you come in and you have a holding because of a lot of traffic, but the weather is beautiful at your destination. The weather is equally beautiful at your alternate. And you have a 30 minutes of holding. You have a 45-minute estimated approach time. And in that case, when you have a reasonable certainty that, I might as well land here as I land over there, well, then you can use your alternate fuel to your destination. So you can kind of rebrand your destination as your alternate and stay in there. You still cannot use that final reserve fuel. Whenever that's a risk of using that fuel, it's a fuel emergency. But there are possibilities to stay and kind of commit to your destination as well. Guys, that's what I had about traffic jams in the sky. If you have more questions about this, as always, come into the Mentour Aviation app. You have the free download links to both iOS and Android down here. And if you love this kind of information, If this is the kind of videos that you are enjoying listening to and watching, well then make sure that you have subscribed to the channel and that you've ticked the notification bell. Very important that you tick the bell, guys, because when I do live streams, when I send out surprise new videos, unless you've ticked the bell, then you won't know about it. So do that now. I want to send a huge thank you to the sponsor of this episode, which is Audible. Now, Audible, they have an enormous amount of audiobooks, comedy shows, news outlets, and I always, like I was saying before, when I am sitting, commuting to work or to a different base in the network, I always listen to a good audiobook because, like I'm guessing you are, I love learning new things. Now, an Audible book that I think that you would really, really enjoy is The Last Days of the Concorde. And if you use this link here below, which is audible.com/mentorpilot, or if you're in the US and you text mentorpilot to 500, well, then you get 30 days of Audible absolutely for free. You get one audiobook of your choice and 2 Audible originals. So use the link here below, click it, check it out, and let me know what you think about it. Wherever you are out there, guys, I hope you're doing absolutely fantastic, and I'll see you next time. Bye-bye. Right, guys, I really hope that you liked that. If you want more content like that, more aviation content, well then, check this out. I hope that you have subscribed to the channel and that you've highlighted the little notification bell. See you inside of the Mentor Aviation app and have an absolutely fantastic day. Bye-bye.